Hello, everyone. Today, we're going to have a presentation regarding the advances in fingerprint technology and forensic science application done by Mark Bangoy, Sofia Duque, and Luis Rincon. So, we're going to be talking about the history, the methods, the newest technology, and the different applications of forensic science and the analytical chemistry that relates to forensic science. So, the history. How forensic science started. In the early years, the field of forensic science has come a very long way since its recorded beginnings in the 1700s, when the Chinese used fingerprints to establish the identity of documents and clay sculptures. In the 1800s, there was a substantial progress. The first recorded use of fingerprints to solve crime, the development of first microscope with a comparison bridge, the first use of toxicology in a jury trial, the development of the first crystal test of hemoglobin using Hemin crystals, the development of a presumptive test for blood, and the development of tests for the presence of blood in a forensic context. In the 1900s and the 21st century, there was a great progress in technology. So there was a forensic science because of that. Chemistry was obviously a big factor on the change. In the 21st century, oh wait, no, the 1900s. In the 1900s, the development of the X-ray technology started. In the 1940s, the evaluation of the gas chromatograph and the mass spectrometer. And in the 21st century, it blended science and technology, especially with all the advancements in the 21st century, everything was possible. Another additional facts regarding the 21st century is that there was a development of a new scientific crime fighting capabilities and methods, including the use of data banks, high-tech equipment, teleforensics, and training involving the use of simulated crime scenes. Some of the methods that were used, like fingerprints, let's give it. How are fingertips collected? The background. Detecting invisible fingerprints is an important task in the forensic science branch, a branch of science that helps criminal investigation by collecting and analyzing evidence from crime scenes. Dusting is the easiest method to collect them. The use of powder makes the fingertips visible, and therefore you can tape it in another surface and analyze it. Fingertips, these invisible latent fingerprints are made of water, fatty acids, amino acids. To make them visible, you need to find one of those substances. Chemical developers. These chemicals react with specific components of latent print residues such as amino acids and inorganic salts. The anhydride causes prints to turn a purple color, which makes them easily photographed. A DFO is another chemical used to locate latent fingerprints on porous surfaces. It causes fingerprints to fluoresce or glow when they are illuminated by blue-green light. So some of the newest technology that was developed is through metal objects. In 2008, scientists at the University of Leicester in Great Britain developed a technique that will enhance fingerprints on metal objects from small shell casings to large machine guns. They found out that chemical deposits that form fingerprints have electrical insulating characteristics, which can block electric current even if the fingerprint material is very thin, only nanometers thick. Another technology that was discovered in 2005 was made by University of California scientists working at a laboratory that used micro X-ray fluorescence, or known as MXRF, to develop fingerprint imaging. MXRF detects chemicals such as sodium, potassium, and chloride in fingerprints, as well as other elements if they are present. What another technology that was invented is another technique that involves non-invasive procedure. The technique has several advantages over traditional fingerprint detection methods that involve treating the suspect area with powders, liquids, or vapors in order to add color to the fingerprint so that it can be easily seen and photographed. Using traditional fingerprint contrast enhancement, it is sometimes difficult to detect fingerprints present on certain substances. The MXRF technique eliminates that problem and is non-invasive. The application of chemistry in forensic science. Aside from being used for aside from being used for identification of suspects, the contents of blood on a crime scene can be evaluated to reveal the presence of substances. For this evaluation, a chemist will perform a chromatography test, which uses intense heat to separate the blood into different contents. Afterward, a chemist determines the level of substances such as alcohol or medication that would affect the suspect's locate actions and motivations during a given crime. Chemistry is often used in crimes involving firearms in order to identify information from recovered bullets and residue. If this residue matches that of the bullet found in the victim, there is evidence that the suspect recently fired the same type of firearm responsible for harming the victim. If no gunpowder residue is found on a suspect, a chemical analysis of the bullet can still reveal information such as the type of firearm used and how long ago the bullet was fired. DNA forensics is used in criminal cases to match the DNA of an individual to that of body cells left at a crime scene, such as skin cells, hair, semen, or and blood. The FBI most commonly uses SDR analysis for its cases. With SDR analysis, chemists take DNA samples from areas at the crime scene. These are then compared with the DNA profiles of individuals booked in a database to identify suspects. DNA forensics is used in civil cases such as fraud, forgery, or negligence. DNA forensics are used to identify the purity and content of food, water, and pharmaceuticals to ensure that they meet required legal standards. Now we're going to get to the part of the analytical chemistry and its role in forensic science. Forensic toxicology studies the effects of poisons and drugs on the human body. Analytical chemistry is useful to interpret the effects and quantify the concentration of the chemicals present in biological specimens. To provide reliable data, hair, nails, urine, blood, and brain tissue are useful biological specimens for forensic toxicologists to draw interpretations of various cases. They also use some sort of drug analysis. And regarding to forensic science, a range of evidence varying from liquids, solids, to plant materials is submitted to forensic science laboratories to analyze the drug samples collected. The procedure involves physical analysis such as the volume, the weight, and the unit count. The process of screening to detect the drugs by chemical spot test would then be conducted, followed by the confirmation test, and then the target compounds can be detected by their retention times compared with the standards. Now, people use trace evidence in forensic science. Trace material can be used to link a crime scene and or victim to a potential perpetrator through comparative analysis. These types of evidence exist in traces and cannot be seen by the naked eye. The characterization of trace evidence requires knowledge of analytical chemistry, as the results obtained can be in a quantitative form by how much samples are recovered, or qualitative form, which is the identity of the trace material. Characterizing trace materials include examining both physical and chemical properties. And that's going to be it. Thanks for watching.